I would like to recommend that PCB designers be a little courageous in their designs in 2022. I would recommend that to be a New Year's resolution for them.
Well, what do you mean by courageous? Do you mean just pushing the envelope in terms of like, what your capabilities are, getting right up to the edge, or maybe pushing a little over?
Yeah, exactly. Yeah, understand what is the edge of the envelope for your fabricator and push them there.
Hello, everyone, and welcome to the OnTrack podcast. Today, I am talking with Amit Bahl, Director of Sales and Marketing at Sierra Circuits. I think it's going to be a really fun conversation talking about DFM, talking about design outputs, and also some of the initiatives the company is developing to provide even more resources to designers. I'm really happy to get started. Let's go. Amit, thank you so much for joining us on the OnTrack podcast.
Hey Zach, how are you?
I'm doing great. How are you?
Fantastic. Happy New Year.
Yes, Happy New Year. This is actually the first podcast of the new year, so it's very exciting. At least the first one that we've filmed in the new year. So this is going to be interesting, especially given a lot of Altium's focus on designing with manufacturing. We want to have people who work at manufacturers on the show, like yourself, and I think I see you a lot on my LinkedIn. So it's very nice to actually talk to you on camera instead of just commenting through LinkedIn.
Absolutely. It's a pleasure to be here, and I think we all have the same mission to educate designers and bridge the designer community with the manufacturing community. So it's a pleasure to be here and talk about these important topics.
Yeah, absolutely. You're not the first manufacturer that has been on the show, but you are pretty prolific, and I think the company is pretty well known around the web at least. You guys have a lot of resources that really help designers, and I think a lot of the focus on helping designers get through manufacturing successfully is really important. One thing I wanted to ask you is actually, how did you get into the PCB industry?
Oh Lord! So my dad started Sierra Circuits in 1986, and I was a little lad at that time, and so my summer vacations were spent running the drill machines and packaging circuit boards and all of the things that no one else wanted to do. So I basically grew up in circuit boards. Yeah. So
That's really cool. And then you went and did it as a career. I grew up in a cabinet shop, running a different kind of drill press. So
awesome.
I'm glad I didn't end up as a cabinet maker, though. It's more fun. It's more to do it for fun rather than as a career. But
Absolutely.
yeah, I had kind of an odd entry into the PCB industry. So it's actually kind of interesting to hear someone that like grew up around PCB shops and actually manufacturing.
Completely. Yes, it was every single thing that, the company grew into was like the first of. So we were one of the first to install a DFM tool called Valor. We were the first to install a LDI machine or a laser direct imaging machine. There was a lot of firsts that I saw, through the years, so that always made it exciting. And being in a manufacturing plant growing up, you have a lot of dads and you have a lot of people telling you what to do. So that was interesting. So
Yeah, I'm sure.
never a dull summer.
Yeah, I'm sure it's similar to a cabinet shop, but probably a lot more interesting than sweeping up dust. So
There's PCB dust. So
that's true. That's true. And I think for some people, that's the manufacturing floor for a circuit board shop can seem what's the maybe a little intimidating, um, different than what you would expect. Because when you think electronics manufacturing, I think everybody's mind goes to semiconductors, and they imagine the bunny suit and the guys at Intel or AMD or wherever, and not necessarily PCB shops. But without the PCB, why do you even have computer chips?
that's so true. That is so true. Yeah, the PCBs are literally the backbone of electronics. And there's a lot that goes into PCB design, and PCB manufacturing. So, uh, you know, there's a lot to talk about. So, one thing that I encourage always is to do a tour of your manufacturing facility. So you'll see firsthand what does it take to build a circuit board, and it's not an exact science still, right? So it's been around, the industry's been around for a long time, but it hasn't really caught up to the level of sophistication of a chip manufacturing, So it's still an art form in a lot of ways, uh, to build a circuit board. So it's a lot of people dependency, process dependency, and equipment dependency. Um, so it would be interesting if you haven't toured a PCB fabrication facility to definitely do that. And Sierra offers a virtual tour, so you don't have to leave your desk. And in the age that we're in, you can get a tour virtually and kind of walk through the factory with us. So I encourage people to do that.
Yeah, I seem to remember seeing that at your booth at PCB West a couple years ago. I believe
Yeah,
you guys had something like that there. That was pretty cool.
yeah, yeah,
You get to see the video of the guy over, pulling something out of the etching vat, and it was pretty cool.
yeah,
But
yeah.
you brought up something important, which is like the level of sophistication in PCB manufacturing. Why do you think that is? Why is the PCB manufacturing space, I guess you could say, behind in terms of the level of sophistication? Is it just investment? Is it attention? I mean, what do you think that is?
Ooh, that's a good question. I mean, I have my opinion. So my opinion is that, the PCB manufacturing, hasn't gotten the level of investment by the manufacturing equipment vendors that is truly needed. So we're constantly trying out new equipment, and you know, may be good, may not be good. So we're buying a new piece of equipment, testing it, and throwing it away if it doesn't meet our standards. And standards are really driven by the customers. So I think that two reasons. One is, people are a little shy, customers are a little shy of pushing the edge of the envelope sometimes, because they want every board shop to be able to build their design. So sometimes they're not pushing the envelope in that direction. And then the second thing is that the vendors who supply us our equipment, they're a little slow on the uptake. So it's all about the OEMs or the individual PCB designer. If they're pushing an individual fabricator, they're really also pushing the industry. And so they have to kind of be a little courageous. So if I could go back to New Year's resolutions, I would say I think I would like to recommend that PCB designers be a little courageous in their designs in 2022. I would recommend that to be a New Year's resolution for them.
Well, what do you mean by courageous? Do you mean just pushing the envelope in terms of like, what your capabilities are, getting right up to the edge, or maybe pushing a little over?
Yeah, exactly. Yeah, understand what is the edge of the envelope for your fabricator, and push them there. And be okay with a little learning on both ends. But don't do it just because. Do it because it's going to equal a better product, a smaller package, total package size, or more optimal use of space constraint, whatever that's going to get you a better product. Use that and push yourself and push the fabricator, and be okay with a little kind of a hiccup, because everyone learns that way. That's how you learn.
That's fair. That's fair. I think quite a few shops may balk at that a little bit. I think they want to make sure that they always have high yield because they want someone to come back, and so maybe they are a little more conservative with their DFM recommendations. I mean, what do you think?
Yeah, that's definitely can be an issue. I mean, our culture is that we'll take on projects that are a little outside of our comfort zone, but we let the customer know that, hey, this is a little outside our comfort zone. We're not going to get 100% yield. Is that okay? And the designer can make that choice that it's not okay for this project, or it is okay for this project. Like, for example, we're doing a rigid flex with embedded resistors, capacitance, materials. And that's a challenge, but the designer knows that they're going to have a huge payoff at the end of this project. And we're learning how to use this material properly in a rigid flex environment with heavy copper. And that's something that both we benefit from as well as the customer. So if the designer chooses their areas that they want to focus on and push the envelope on and work with their fabricators, I think it's good for everybody.
Yeah, yeah, I get what you're saying. And um, as far as capabilities, I mean, it seems that even though the capabilities have advanced over the last 30 years, it still seems really disparate. Like you don't have the drilling machine talking to the SMT line. You don't have what I mean. Whereas if you go in a
Oh yeah.
semiconductor facility, everything is really highly integrated.
Yeah, I think that's a great point, Zach. So when we get the first thing that we do when we get a design, since we're a fabricator and an assembly facility, we look at the design from both perspectives because traditionally these are two separate vendors for a designer and they don't really talk to each other. They actually point fingers at each other when some issue happens. So we get the benefit of looking at the design from fabrication and assembly. So we'll look for things like component overhang or, do your vias need to be filled with a non-conductive epoxy for proper component placement so that your solder doesn't wick in the hole. And so we'll look at things like that. And, so you have to connect the dots both in these two independent processes from a technology standpoint as well as a logistical standpoint. So one example of technology is when a PCB is built, you have to scale the material. And that scaling data is what needs to go to the assembly facility to build a proper stencil. Because just because your Gerber data or ODB data says that this is where that pad should be, after you build the board, it's not exactly where the dimensions don't line up exactly to the Gerber data anymore. So if you're building your stencils off of the Gerber data and not off of the scaled working data, then your stencil is going to be off, and sometimes that can actually cause lots of problems in assembly. So to your point, a lot of integration is needed both within a PCB fabrication facility itself as well as across fabrication and assembly.
Yeah, that's actually a good point because I think a lot of people are used to working with, a fab house, and maybe they communicate with their assembler. Here where I'm at in Portland, one of the fabricators that I like to use, they're actually kind of like joined at the hip with an assembler, even though the assembler is a different company, but they still have a really close relationship. So, the fab guys at least know what the assembly guys care about. Now, there have been other projects where it's like, I've got a fabricator because I'm doing something on Rogers and they can turn it in, 6 days, whereas the other guys are going to take 3 weeks. So I'm going with this other company for fab. They don't know what the assembly guys want. And luckily I haven't, shot myself in the foot yet on that type of thing. But I'm wondering, it sounds like from looking at all the design outputs, you guys can actually tell when there's going to be a problem and be able to really advise how the design needs to change to make sure that you don't have low yield or you don't have bridging or you don't have solder problems, whatever it's going to be.
Yes, and I think that's where Sierra Circuits shines. We really always try to give good feedback to the designers, and so we have a customer portal. Oops, sorry. We have a customer portal that gives that feedback to the customer in real time, both from a PCB standpoint as well as an assembly standpoint. And getting that feedback as a designer, I think, is critical because everyone has their areas of expertise, and a designer's expertise needs to be more manufacturing. But really they're not a manufacturer. So getting that DFM, DFA feedback, and really working, with that fabricator and assembler, I think that's super critical. And so we share a lot of information with the customers in that regard in terms of how can they improve their design this time around and also, next time around. So, yeah, good point.
Yeah,
Um,
yeah. Oh, sorry, go ahead.
no, no. I was gonna say that you know when when we first get a file from a customer, so we look at that from, first completeness of the data. So there are still lots of people who don't have proper document control, and they'll miss the fab drawing, or they won't send us the XY data, or they they're missing information, or worse, they're sending us ODB data and Gerber data and not really giving us direction on which set of files to use. So for PCB manufacturing, we'll default, to whatever we want if the designer doesn't tell us. For assembly, ODB is always better. So we'll look at the file set for completeness right when we get the data. And that's when, once the data set is good, that's when the DFM DFA starts. And then we'll feed back on the actual, if the route is too close to the edge of the board, or the pads are too close to each other, or the interlayer clearances aren't enough. That's where we look at all of that. Once the complete data set is good.
So you mentioned sharing, information back to the designer. What's the intermediary for that? Is that just through the website? Does that happen automatically? Do you guys have to put everything through full DFM, DFA first? Is it semi-automated?
Yeah, I would call it semi-automated, not fully automated yet. There's a person behind the portal kind of keying in the information for the customer to see. And it's because, you want to review the information that you post before you post it, so that the information back to the designer is good. And it's a real issue. It's not like a false positive. I think that's important. So we still have lots of engineers who look at that every day, and give the feedback in real time to the customer.
Yeah. And as far as the feedback, like, what is some of the most common feedback that you have to give to customers? What are some of the most common, maybe not mistakes, because sometimes a mistake could be electrically correct, electrically functional if you could manufacture it, but you may not be able to manufacture it. So what are some of those most common pieces of feedback you have to give?
Yeah, there's a lot. There's a lot of that. We spend a lot of our time looking at designs, and I think it's one of the reasons why that question is not easy is because capabilities play on each other. So a very typical one that I think most people know about now is like the aspect ratio of plating a via. If you say what is your minimum hole size to a fabricator, and they say 6 mil via, but you don't ask the next question, which is what aspect ratio can you support for plating, then that piece of information by itself is really useless, because most fabricators are okay with 10-1, meaning that if it's an 062 thick board and you have a 6 mil via, you're going to drill it at 8 and you can plate it down to 6, and aspect ratio is fine, so no issues. But then if you start talking about a 100 mil thick board and still a 6 mil via, that's going to be a little harder for some fabricators to plate. So they can drill the hole, but then they can't plate it. So that's an example of how capabilities play on each other. To really understand that before you just kind of dive into someone's website, read the capabilities, and then try and design something, you should definitely talk to your fabricator and understand, the design rules, and learn what you don't know, by sharing what your task is, what your plan is, and then, getting some feedback early on. The biggest one that I like to talk about also is drill to copper. Design tools don't really have a good DFM for that, because internally, or DRC, because they don't know what we're going to necessarily drill the via at. So in order to get a good rule there, you have to increase your drills by, let's say, 3 mils, and then that run your DRC again, and that would be, you'd want an 8 mil clearance from the edge of the hole wall to the next copper pad or copper feature. That's drill to copper by definition, and that's kind of how you could possibly get around that and measure it early on. But we see drill to copper as an issue all the time, and then as one of those examples of, you can design it and it's electrically good, but it's really not manufacturable.
And then I'm sure you would make the same recommendation, or a similar recommendation, about like drill to drill.
Exactly. Yeah.
Yeah.
Yeah. If you want to do stitched vias, make sure that your fabricator's comfortable with that many vias. Make sure that the spacing between the vias is good.
Yeah, and
8 mils is a rule of thumb. So
well, and it's not just like the pad to pad. It really is the drill to drill, because I would think that the pad to pad could be generous, and yet still you might violate the drill to drill limit.
yes, so the way the outer layers are built, you first drill the vias and then you will image the outer layer after that. So you're kind of aligning to what you drilled to get a good registration on the outer layer. So yeah, it's really it is about drill to drill.
Yeah, yeah, that makes sense. And I know exactly what you're saying. There is a lot of focus on the copper to copper, whether it's a copper pad or trace to some other element, whatever it may be. But yeah, not really so much on drill to drill.
Yes, and one other comment on drill. So you were talking about a connected facility. So for drilling, that's super important. So the PCB material will move after lamination. And so when that material moves, because I mean the whole point of lamination, you're melting your prepregs. They're filling in the peaks and valleys of the etched copper of the inner layers, and things are moving around, right? So things are flowing. The prepreg flows, and so when that movement is done, where do you drill, right? Because your inner layers have all shifted a little bit here and there. Um, you know, you have to optimize your drill to the material movement. So that material movement should be measured and fed to the drill machines, so the drill machines can then optimize where they actually drill. So you're not drilling specifically to the Gerber data. You're drilling to basically the material movement, and you're optimizing from there. So if your shop is not connected that way, then you're never going to get an accurate drill location. So it's really important to have that connected facility.
That's a great point, because I mean, especially with drilling, I think we focus a lot on wander. Especially, as the CNC moves around, it does accumulate some wander, and that's fine. But I've never heard anybody bring up the fact that maybe the material settles after flow, and maybe that misaligns some of the copper. That's an excellent point.
Yep. And when you're dealing with rigid flex boards with different materials, or high speed materials and low speed materials in the same stack up, that's when or two sublams, those types of designs, like the higher tech designs, that's where scaling becomes extremely important. It's a necessity to that build, not a nice to have.
What if there's a resin content mismatch between two different dielectrics? Does that worsen the problem, or would you recommend trying to keep it as consistent as possible, or does it even matter?
Well, I mean, it's a good question. I think that, let your fabricator decide what kind of materials they want to use. I think some people go as far as specifying the exact prepreg styles, on the PCB stack up, but really let the fabricator decide what they want to do. Most good fabricators will lean towards a resin-rich material, both to get good, let's say, uniform electrical properties across the material, as well as it's easier to laser through. The glass bundles always cause kind of a problem, both with wicking of plating and laser drilling, and I could go on and on. But yeah, so a good fabricator, even though the material is a little bit more expensive, would lean to more of a resin-rich prepregs.
And then how are they checking the movement or the misalignment after pressing? Is that just X-ray?
Yeah, so we have machines called Pluritech, and they kind of X-ray into the board. They look for the fiducials and to see how far they've moved, and we re-register the drills to that, or scale the drills to that.
I see.
If you don't have that machine that can look inside your boards, and if you don't have the statistical tools to kind of realign your drills, then you'll never get a good, accurate drill.
Okay. That's very interesting. And yet another reason to call your fabricator before you finalize your stack up and start doing your design. So great info.
Absolutely.
So, I mean,
and
oh, sorry, go ahead.
Well, I was gonna kind of say something about, a lot of the key is, upfront when you're designing your board. So, and, in the last year or two, the industry has been flipped on its head, so we see people, they never send us a final design and say, go build this. It starts off, maybe 2 weeks before their design is done, they're sending us information, to start kind of going over whether it's the bill of material. If it's the bill of material, we're scrubbing it to make sure all the components are available, and we're putting those components in stock so that when the design is done, there's no kind of missing components or hard to find components or long lead time components. So that's totally different over the last couple of years. Um, Getting a stack up from your fabricator is super important. So, we've created a software tool that allows the customer to basically self-serve and get their own stack up and get a manufacturing ready stack up early on. So that engagement early on is key, and you know we're really thinking hard about that and how we could service the designer better in that area.
So these are really your standard, or not, maybe not standard stack ups, but they are based on your, standard material stocks that you carry and what you have data to show is manufacturable with high yield.
Yeah, exactly. Yeah, and we ran a bunch of design of experiments, they call it. So, with these stack ups to get this impedance, we're like 99.9% sure of everything. We're not taking. We ran so many design of experiments that we have our kind of set database now. So if a customer is picking a stack up or building their stack up online with this tool, it's we're like 99% sure everything's going to work out because we ran tests on that stack up already. So,
That
yeah.
makes a lot of sense. Yeah. Well, that's great that customers can take advantage of that hard work that you guys have done ahead of time, rather than getting a controlled impedance design all the way to the end, and then all of a sudden, they find out they have to change track widths on 100 different nets, which unfortunately I did early on a couple of times. So I will admit that.
It happens. It still happens today, but we're trying to like eliminate these, nuances to the manufacturing process that really cause lots of heartache to designers. So I think we got it right this time. So I'm excited about introducing that tool in 2022 to our, to the designer community.
Yeah, that's excellent. I'm really interested to see that, and I think this is great that Sierra Circuits taken has made so much effort to create these resources for designers. Not all manufacturers do that, and I think it's shows the investment that you guys have in making the industry better and making the designer better. I think a lot of mom and pop shops, they're doing their best, right? And I think a lot of shops are just surviving, but it's remarkable that you guys have managed to get to the scale to the point that you are able to create those resources. And then I know that you also have an impedance tool. Is that also based on your guys' stack up data, or what? How are you getting those values?
Yeah, so we created, this is impedance tools are all based on the laws of physics. So we, really worked hard on, building in all of these, all the proper models and all the equations into the tool, and also real world data. So using a combination of both, it's not just a kind of like a, what's the right way to say it? It's not based on just the equations. It's based on the reality of building your circuit board, and what does the impedance actually look like. So
Yeah, and that's actually what I wanted to get down to was, with the material properties, because it's one thing to read a value off a data sheet, but John Coonrod talks about this a lot, is that the value on your data sheet is not actually the value that the signal sees. It depends on, number one, the actual transmission line, but also on how you actually do the measurement, and does the measurement match the actual line that you're going to get. So it sounds like you guys are incorporating the actual material data into what would normally be a theoretical model, where you just have to, I don't want to say guess, but just plug in a value for dielectric constant.
that's right. That's exactly right.
Okay, yeah,
Yeah, we're very excited about the impedance tool as well, and we're going to build it into the stack up.
Yeah, I think I was talking with someone at Altium a little while ago, and he had always said like it would be so cool if we had an extension where you could just like click a couple buttons and the material properties come in, and
Right.
then you could use one of the tools in the software or use their stack up or whatever it is to just automatically set your stack up parameters in the design tool, and then there's no more guessing. There's no more guessing as to the dielectric constant or anything like this.
Yep. Yeah, and it that would be a nice world to live in. So it does, but it does depend on the actuals, the results that you see. So when we're building a controlled impedance board with kind of lots of target layers, we're doing in process cross sections to understand how did we etch. Did we etch well with intolerance? Understanding the press out thicknesses after lamination, kind of feeding that back into the model and making sure we're on track. So this is all in process, and then when you get your final product, if you have good equipment, you can measure the actual trace on the board rather than using just impedance coupons. Impedance coupons is a normal practice, and everyone does it, including us. But if you can also measure on the board itself, that speaks to, reality and what the designer would actually see on their board.
That's a great point. We actually, we had a viewer question on one of the other videos that I did that was asking, what happens if I take like a test point on a high speed board and I like put it off to the side, basically like a stub. And so, of course, the conversation devolves into, input impedance, which is an important concept. But you guys are actually measuring like high speed signals on the finished board. How are you actually doing that? Are you just, exposing a little bit of the copper at the driver and the receiver end? Are you taking advantage of a via? Are you placing like a pad near the driver? How are you doing that?
Exactly, all of the above,
All the
actually.
above. Okay.
Yeah, yeah.
Whatever is easiest for you guys to probe is what it sounds like.
Exactly. And think and talking to your fabricator at the design stage, that's where you can kind of bake these things in. So if you're working on a high-speed design, talk to them and understand how the testing is going to happen. If just getting a piece of paper at the end of the fabrication, saying that, hey, we met your impedance requirements, that's not enough. Like, you got to engage with your fabricator and understand, the details. So the designer has to take the time. So maybe that could be another New Year's resolution. Take the time with your fabricator.
There you go. There you go. Ask them during the tour, right?
Exactly.
Exactly. Very cool. Yeah, well, I mean, we've talked about a lot, and I think this is all just unbelievably important information. And I'm people like to call me a design expert, but I think that even if you're good at what you do, there's still time to learn something new. So this has been really great to talk to you, Amit. Is there anything else you want to tell us, or you think we're good?
No, I think we're great. So, Zach, Sierra has a lot coming out in the early parts of 2022. We have a new website we're launching, full of good knowledge-based information. So, if designers want to refresh themselves on what is manufacturing look like, what are the key things that they should be looking out for, they can go to our new website, and see all that information there.
Absolutely, absolutely. And we'll link to you guys in the show notes so that people can check it out. I think we'll also link to some of the tools that you guys have so that people can go and try them out for themselves. This
That'd
has
be
been,
great.
yeah, absolutely. This has been great. Amit, thank you so much for taking some time to talk to us. This has been very insightful, and I always love learning as much as I can from manufacturers.
Thank you, Zach.
Thank you. To everybody out there listening, don't stop learning and stay on track.